Right, so one of the big things is when you have hard or difficult curves, all right? And these might be functions, they might not be, okay?
You don't even know?
I don't even know off the top of my head.
Wait, so if it's not a function, can you still find it?
Sure, we do it all the time. Plus differentiation, right? X squared, y squared plus 9x squared equals 7. All right? So everybody, when you see these, it says use logarithmic differentiation to find dy dx. You got to remember from pre-calculus your log rules. There are 3 of them, okay? The quotient rule, which says if you're dividing, you're subtracting exponents. The product rule, which says if you're multiplying, you're adding exponents. And finally, the power rule, which says if you're multiplying exponents, you're taking the number to a power. We're going to use those 3 here today to do these. All right? So, on the first one, the first thing I got to do before I even worry about taking the derivative is I have to take the ln of both sides. And when I say log rules, it could be ln rules. So I take ln y equals, and I'm going to immediately do this, ln of stuff to the 1/4 power.
Can you take it down now?
Because the first thing we're going to do then is rip that 1/4 in front of the ln, okay? And we're going to manipulate this until it's much easier to deal with. Because right now, x squared plus 1 over x squared minus 1.
So now you're going to subtract.
Yeah, so I'm going to make this quotient, right, into a difference, all right? So I get ln y equals, now be careful, right, 1/4. My board's going to be a little difficult. Does everybody realize that the 1/4 goes on both, right? Because if we do this portion, it's this portion, right? But I just put the 1/4 on both. I distributed it in my head already, all right? Now I look at this and say, hey, this is a derivative I can easily do. We only have to memorize one derivative, well, 2 derivatives. E to the x is e to the x, but in this case, the derivative of ln x is 1 over x. Now, these are all chain rules at this point. Not the first one. Good point. Not the first one. The first one is 1 over y dy. Now, we are going to immediately do what? Divide by dx. So, I'll write dy dx because we're going to do that. You could have wrote y prime. And over on this side, everything is in terms of x. I will write no dx's. I will say them, but not write them. So the first derivative is 1/4 is a constant. That's the beauty. The power now becomes a constant, right? So it's 1/4 times 1 over x squared plus 1 times, what's the derivative of that? 2x minus 1/4 times the derivative of ln stuff is 1 over stuff times the derivative of that stuff, which again is 2x. All right? And again, both of these terms on the other side would have had dx's, but we divide by the dx, so they disappear. All right. And we're left now with just kind of cleaning this up. All right? So on the other side, and I wouldn't clean it up much. Here's what I would do. I'm going to write dy dx equals, and I'm going to leave space for y. And I'm going to multiply both sides by y, right? And cancel the y over here. So this is going to be y. I'm going to erase that y in a second, though, okay? Times x over 2 times x squared plus 1 when I simplify, minus x over 2 times x squared minus 1. Now, I suppose I could do some work and make it one term, but I'm not going to bother. All right? But I am going to say y is what? Well, y is that 4th root of x squared plus 1 over x squared minus 1. And everybody, I sure hope I don't need the second derivative for concavity's sake. But that's a derivative. I can know whether it's mins or maxes. I I use a calculator or a computer program to find the zeros, right? I probably don't want to solve this by hand. All right. The one thing I know is that this thing is never going to be 0 because that root there is never going to allow a 0, is it? X squared plus 1, that's parabola. So it'd have to be whether this stuff could ever be equal to 0 for that, but we're not worried about that now. And that would be the answer. That is dy dx. This one was much more complicated than the next. Rolling on to the second example, I'm going to box all this stuff, get it out of the way so I can be a little bit cleaner here. And again, I think the next one's easier than the first one, but some students tend to freak out if they have x in the base and x in the power. But logs give us the ability to do a lot of things. And again, you should panic right away that the x is in the exponent. You know you can't really deal with it there. Okay, exponential growth, you can't write it as 1 over x times stuff and then have the exponent be 1 over x minus 1. You can't reduce it by 1 and stuff. So I take the ln again at both sides. And I'm going to start skipping steps. Does everybody see what I did? I already brought the exponent down, right? That's the whole point of taking the ln. Now, everybody, guess what I got going on the right side? I think what I have on the right side is a power rule. Not power rule, product rule, right? X negative 1 times ln x. Alright, so let's start taking the derivative. Again, I'm going to divide by dx immediately. So it's this on this side, and then I divide it by dx. I won't have to worry about the dx on the other side. We automatically do this. Alright, I'll handle the first factor, or first part, f, right there. Derivative of x to the negative 1 is negative 1 x negative 2. Alright. Got a dead spot over here. I'm going to have to move this over here. Times ln x still. Plus x negative 1. And the derivative of x negative 1, of ln x is 1 over x. And everybody, these would both be dx's, but we divided by dx already. So now, this requires some cleanup. I see this other side, before I even think too much about it, I get negative ln x over x squared, do you guys agree? Plus 1 over x squared. Oh, this is going to be a little pretty, right? So I see a common denominator by chance. And I can multiply by y, which immediately I knew y was x 1 over x. So there's y times, well, I'll write it in order so we see it. I probably would write it as 1 minus ln x, or if there's a multiple choice answer on, it would probably be written as 1 minus ln x, not negative ln x plus 1. So we should see that that could be either way. And we just did the logarithmic differentiation. Took a very complicated, in fact, the second problem, a problem we couldn't do by hand, okay, and solved it. On the first one, we took a problem that we could have done using the power rule, and then using the chain rule, using the quotient rule. Oh, I'm getting a little sick to my stomach already, thinking of all the rules I have to use on the first one. But again, logarithmic differentiation, you have to practice it a little bit. Keep going. AP's close.